So let's get started. So first of all, thanks to everyone who's been present here. I know it's Sunday, but I hope for the next 25 to 30 minutes, we're going to make this talk pretty good and you'll learn something great. And so as mine, so it's kind of a journey for the next 25 to 30 minutes. Hopefully, let's get through it. So today we're going to talk about Crimeware kiosks. We're typically going to focus on one of the main scenario, which means like we're dealing with botnets, we're dealing with different set of crimeware. But in this particular talk, we are going to look into how the attackers or the botnet operators are deploying botnet command and control panels. This is one of the most important things to know when we talk about the security intelligence in the field of malware. And this actually gives us a lot of interesting insights, and then we'll take a look at it. So a little brief, I think, background on mine. So I think I just want a little disclaimer. Most of the research that we're going to discuss during the course of this talk is totally an independent one. Nothing relates to my employer, because I always believe that security community has given you so much. We are in the world of shared responsibility model. Like, let's stick to it. But at the end of the day, it is always our individual strengths to actually give back to the security community as well. So that drives me towards a lot of interesting things that is apart from my job responsibilities. So we'll take a deep dive into later down. So let's get it started. So what we're going to talk about today. So we're going to look into the world of cybercrime. We're going to talk about why botnet are being growing. We're going to look into the basic HTTP-based command and control communication channels, try to see what it's all about. We're going to look into some of the real-world command and control panels, how they look like. And then most important part is that what are the techniques that you have to opt to actually go after and find these kind of command and control panels, typically pressing the channels on the HTTP protocol. Then we have we did some empirical analysis. We're going to discuss the results of that stuff that actually gives you more feel about what it is all about, what we are talking about. Then we have a little bit discussion on the arms race, and we'll conclude with the question and answers. Yeah, so I'm going to start with a little analogy, right? I mean, these days, the more of the security threats are relying in the context of data movement, right? I mean, earlier we have some complexities around, data storage and all that. We have been advancing in that field. But right now, with new compliance coming up, GDPR and all those kind of things down the lane, we are more individualistically tying after the context of, which I used to call as like data movement chaos, right? What did I actually mean that? At the end of the day, with the last 10 years, mobile revolution is occurring, new devices are coming up. So what I feel that more devices, more targets, more threats, more exploitation. And more exploitation means, which results in more security breaches. If you've seen around in the recent times, right, we talk about we have many security controls, like solutions, devices, everything has been deployed. But still, we are facing security breaches. What is it all about? So considering that scenario, it's very important to understand the complexities that are involved around the data movement. Similarly, which basically resonates back to the scenario which we used to call it more devices are present in the world. More devices means like more launch pads for the attackers to trigger the attacks. That's why in the context of bots, what does bot mean, right? Basically, you compromise the device, you install your malware, it become a part of the botnet, and then you can perform a lot of nefarious activities using that network of bots. But again, at the end point, the more important part is that in technology, things are growing exponentially, so as the threats, so as the infections. So let's take a little look into the growth in botnets. If you see around what we are seeing in recent times, new botnets are coming out, whether these are developed with the new code or the reuse of the code. I know in 2008, SpyEye came in, Zeus came in, and then there are a variety of those botnets, using the same code, Citadel one, and a lot of other things. These days, we are looking into infection of Tesla agent and a lot of other botnets. But this thing is actually growing exponentially. And that actually a little bit worrisome down the lane, because at the end of the day, a lot of nefarious activities will be done on the internet. That involves users, that involves devices, that involves organization, enterprises, whatever it is. Attackers are basically after a scenario to get the money, right? What I mean by that is, earlier when we have seen in the growth of botnets, people are doing it for fun and profit purposes. We still see denial of service, but these days, those basically adversaries are financially motivated. And that's what we are seeing these days. At the end of the day, if they steal your credentials, I mean, they're going to sell it in the underground community. They have like well-defined structured marketplaces in the underground economy, and they are just strengthening that economy day by day. So that's what we are feeling right now. Just another one, stats before we start the real talk. Growth in botnets, right? And then we can see the lot of variety of botnets coming across, and that is targeting IoT, or either they are targeting different devices, desktop, laptops, whatever it is. The most important point in understanding the botnet growth is like how they are abusing the protocol. So I'm just gonna take a deep dive a little bit into the basics, and then we're gonna talk further. So when I talk about protocols, I always feel that at the end of the day, there are standard protocols. There are an HTTP protocol, IRC protocol, P2P, and a lot of other different protocols. But still, at the end of the day, it's a client-server model, right? I mean, your systems are infected. They have to connect back to the CNC server, and then they are still using the same protocols for communication. The most important artifact is that how they are abusing that protocol. Are they using the similar? Are they using the same way, the way RFCs have defined the protocols? Or are they actually screwing down the process of using the protocols for CNC communication? So we actually take a look into it. So let's start with a simple basic CNC architecture, specifically for the HTTP-based botnets. So let's say if you look at this particular graphic, right? So on this side, you can clearly see that there's a bot executable, which is what I actually mean by that. Your system is compromised. Malware is running inside it, which we call as a bot in the context of botnet terminology. Now, since the bot is running inside a system, it has a capability. It's all powerful, right? It can subvert the integrity of client application, whatever it is all about. But we are focusing here on the CNC communication channel, not the infiltration one, because it has already infected the system. But we're going to focus primarily on the protocol scenarios. So the bot has to send your information back to the CNC server, right? Look into that context. Is it right to say that, okay, bot extracts the information, is going to send it back to the server will receive it, process it, store it in the database, the attacker can come back, look into the information, and then sell it in the marketplace. But if you look at the three different main components, before your data gets back into the CNC admin panel, there is a CNC gate as well, which is a very important design component of the CNC deployments where we talk about botnets. What that gate exactly means, the gate is basically actually scrutinizes every single communication that bot is making or sending data back to the CNC server. So bot is sending data, gate gonna filter it, gate's gonna look into it, whether some data is coming up, which kind of bot is sending what kind of data, whether there's a checksum associated with that data. If there is any anomaly, the CNC gate's gonna filter that traffic out. So it's like cleaning process, right? When the security researchers come back and they do some kind of analysis, they can still connect back to the CNC domain, try to mimic the behavior of a bot. But in that case, there are certain mechanisms they have to go after, try to make sure that they mimic the traffic exactly the same way bot is sending the traffic. That's why these adversaries, botnet operators, they come up with this design of CNC gate, right? They want to make sure that they get the clean data. In underground economy, the value of clean data is way, way much more than the garbage data, right? Because that's where they get more money. Because the data is clean, it's validated, it's verified, and that's what they are going after. So all these steps, design components are tying back to the underground economy, like how they're going to collect the data, how they're going to sell the data, what kind of data is getting back into the CNC panel. But this is a very important artifact and the design component of that. So bot is going to send HTTP traffic, HTTP request in the form of HTTP post back to the CNC server, but the gate is going to filter it, making sure that the data is coming as expected. So in this case, I'm trying to solidifying the fact that I was discussing earlier. It's not something we are just discussing it, but look at this. So we were analyzing some of the, the code of this botnet, Pony botnet, which we try to find. Actually got a hold of, while doing penetration testing of some of the CNC servers, try to make sure that how it is being deployed and what it is all about. So when we were analyzing the code, it was very, very clear that the concepts that we discussed earlier was implementary right away. So very simple use case scenarios. What if no data is sent back by the bot to the CNC server, right? So the gate is going to come back, it's filter it. If you look at the code is there and it's going to tell you that how they are filtering it. It's a PHP based code, but it's validating the fact that gate is there. It's a primary component of the botnet C&C architecture. Looking at the second one, this is the admin panel. So we discussed about there's a gate, then there is an admin panel. The admin panel code is going to show you how it's interacting with the database, what kind of whitelisting it has implemented, and how the data is going to go back into the tier 3, which is called into the database. So gate and the admin panel, they are interrelated, right? Every request has to be validated and verified by the gate before it goes back to the CNC domain. So this is a basic architecture we're going to target, and then we'll discuss about the results on the empirical analysis. So before moving further, I want to give you a feel of it, how the real world CNC panels look like. So if you look at this slide primarily, so we have like Lockybot CNC panel. There is a Tesla agent CNC panel. Tesla agent is a kind of stealer that is being distributed a lot these days, and this basic purpose is to steal credentials, send it back to the CNC server, store it there, and then reuse it in the cybercrime marketplace. Another one is the Pony CNC admin panel, Citadel CNC admin panel, and things like that. One of the important fact about Citadel is that it is basically originated after reusing the same code which Zeus did. So some of the mistakes that Zeus botnet had, like in 2009, 2010, this botnet overcame. In 2014, I think we gave a talk in Black Hat where we discussed about how to actually pen test the CNC panels, and we highlighted some of the weaknesses in panels. And actually, these days when we test the panels, like in 2018, after 3 years, most of those weaknesses have been eradicated. So which means that attackers are also looking what kind of research that are going in the security research community, making sure that they fix those issues so that the infection process goes stronger and stronger. The next set of panel, if you look at the administrator panel, is the Coin Miner, Coinbase, and a lot of other things, Godzilla 1 and all that. So all these things is try to give you a feel about the infections that are running inside the compromised machines. They are using Bitcoin mining and other kind of stuff as well. So all those information still goes back to the CNC servers, making sure that whatever they mined, they get the idea, the data, everything up from the compromised machine. And these are very important, like whenever you're doing, penetration testing or try to test these kind of CNC servers, you encounter all these scenarios a lot. But then you have to have like all techniques and tactics, try to go after, performing reconnaissance and other kind of things, try to find out if there's some kind of, exploit that you can trigger to actually get some data out of it and some stuff like that. But at the end of the day, you deal with all these kinds on your regular day purposes. And the most important part is that, you need to make sure that you got a hold of it, you get maximum intelligence gathered out of it, try to make sure that you use that intelligence to build strong detection solutions, or try to share that research with the community. If somebody wants to use it, they can go ahead and have it. So right now, we have talked about the basic architecture. We talk about design components of the botnets. Now we look into some of the CNC administrative panels supported by some of the botnet codes and all that. Now, let's talk about some of the techniques that what we use to actually go after and finding CNC panels, because we understand what it in theory it looks like, but at the end of the day, we want to make sure that as a security operation guy, sitting in the cloud, sitting on a data center, wherever it is, even on my local network, I want to make sure that what I have to look into so that I can detect and fingerprint CNC communication, typically on the HTTP level. So these are the wide variety of techniques that we use, but concentrated on specific set of attack vectors. So first of all, we all talk about static analysis, performing reverse engineering. Attackers are making mistakes. They are hard coding the things, hard coding the CNC domain, CNC URL. You just reverse engineer it or debug it and get the idea out of it, how the code works in the underlying assembly, and then, got a feel of it. IDA Pro, all these kind of tools are there. So you get a feel of it, and then you got able to find the CNC domain, and then you start your penetration testing afterwards. But attackers find out that, okay, this is a very easy technique, just passing the value of your CNC domain URL as a string in the binary is just pretty easy. Strings, a lot of other things, tool you can use to get it done. But then they came out, okay, we do want to do that. We're going to have like some kind of different mechanism or different technique to go after. which we call as like domain generation algorithms and some advanced algorithms embedded in the binary, so that when the binary or the malware executes in the system, at the same time, the algorithm is triggered in the system, and they actually generate the CNC domain, the CNC URL dynamically. So in that case, until unless you run the malware in a controlled environment, you basically attach it to the debugger, you don't have any idea what the CNC domain is going to look like. Until unless you reverse engineering it completely, try to extract the algorithm, derive from the algorithm, you draft a pseudocode back into the Python, write the proper code, and then you just get the idea of how the domains are being generated. So those are the part of domain generation algorithms. And when DGAs generate domain, we term them as like algorithm generated domains. So you can build CNC URLs out of it as well. So in dynamic analysis, in a controlled environment, in a VMware, you go after, you run the malware, you dump the PCAPs, you start analyzing, how the network traffic looks like, HTTP level, GET requests are going on, POST requests are going on, and for trying to find out anomalies in that. For example, simple anomaly, you're sending a data over HTTP post, but the body is encrypted. Basically, it's a deviation from the HTTP RFC standards, because HTTP is a clear text protocol. You don't need to have any encrypted content and body and all that. So it's a couple of these things. Usually you get this intelligence, you analyze more malware, try to see characteristics of other bots, and then you figure it out. Okay, these are some of the techniques they are using. Other use cases that, whenever they send, they make mistakes, like Russians, other guys who are actually drafting, or in some Europe or some Asian, whenever they are drafting any kind of writing a code, they make a mistakes in HTTP headers or some other things. So these kind of anomalies you keep on encountering while you're doing reverse engineering, dynamic analysis, and some stuff like that. And the third is the most important part. From the static analysis and from the dynamic analysis, you extract some data out, you build some signatures. And the most important part that we all love is Google, right? So using Google search docs, you can still detect a lot of CNC panels. I'll show you in a bit. You have to build patterns, use Google Docs, and then just run your Python code, and then just keep on detecting some similar set of web deployments. And you can clearly see that it's so easy that Google indexed the CNC bots as well. The problem is that most of the deployments at the CNCs of these kind of stuff, they don't put up like restriction on the basically search bots, right? So they just go after, find, okay, just try to get every HTML page into a cache, and then you have the indexing ready, and then you just use the Google Docs, they give you a feel of it. Other one is like hosting providers, right? Data centers, or in cloud, or AWS ones, right? So where people are hosting their VMs, and those VMs are also getting infected, compromised. People are deploying CNC panels there as well. So you need to have like some scanning scripts you want to go after, and then make sure that you find some kind of patterns there as well. At last, one of the important fact also is about threat intelligence gathering from the open source platforms, or like Pastebins and other kind of content sharing platforms. You get a pretty good feel of it. There are many good players in the market right now which are actually mining the information for us as well. But combining all these, there are a couple of other techniques as well, but combining all these techniques together, you can really build a good fingerprinting solution and try to see that, how I need to detect CNC panels for specifically that are using HTTP protocol. So let's just move further and give you a quick feel of it. Just a quick snippet of the reverse engineering. So looking into hard-coded CNC. So you can clearly see one of the examples showing the malware is actually using Tor network to actually send the data out. Other one is a pseudocode that I drafted after looking into the algorithm, and then we just wrote the Python code, try to see how the domains are generated in an automated fashion. So you have the seed value, you have the token, you just put that in after reverse engineering, draft the code, put that in, and then when you run the Python code, it's going to give you all the domains, right? So that's the way it is being done from the static analysis perspective. Looking at the dynamic analysis, when we try to look into the network traffic, you can clearly see that this one on the top, the first snapshot here, the bot is actually running the domain generation algorithm. It's generating the domain on the fly, and it is sending the domain DNS queries, try to make sure that one domain out of the 100 should resolve, which attacker is going to actually set up for the CNC communication. So it's going to start in the iterative fashion, first domain, second domain, until 100, or whatever the numbers are, right? One domain is resolved, it get the IP address, it's going to start communicating. But you can't detect these kind of things directly back into the reverse engineering unless you fingerprint and try to find out what that algorithm is all about, run in a controlled environment, get all the domain, and then try to see from there. Once the domain is resolved, the bot is actually sending data back to the CNC server using the HTTP protocol. And that's the example I was giving you earlier, like, it's still using the post, it's HTTP communication, but the data is encrypted. So these kind of anomalies, we need to figure it out to make sure that how to look at the data from the compromised machines. Interesting one that I was talking about on the Google Docs or any search engine docs here. So this example is primarily for the Lockybot. So we analyze a couple of CNC panels and we find out that the author of this particular botnet, they are actually using a random web page name with the PHP one. Basically, it's a PHP-based random web page name, but it wasn't exactly a random page, right? It looks like if you see that it's generated random, but you see wide variety of deployments, the page was the same. So it means that it just tried to fudge you from the perspective that there might be some other random generated web pages, but it wasn't the case. So you build a simple signature, you run it through the Google Doc engine, and then you can clearly see you started finding CNC panels on the top of it, right? So this was just a simple Google search, and you can clearly see the panels are coming up. You can see which domains are compromised or specifically created for deploying the CNC panels. But this is one of the most important. Another one, the example is the Tesla agent. You can again build up a Google Doc what it is all about, and then pass it to the doc engine to get a feel of it. And you can clearly see the Google is now indexing the CNC panels that are being deployed either on compromised domains or basically the one that we discussed earlier. But you can clearly see that you can still get a hold of it, that where the Tesla agents are. But this kind of things, these kind of signatures or these kind of intelligence, you can only gather once you do perform some kind of static dynamic analysis or a correlation between all those techniques to get a better feel of it. But these are the most important techniques. And it's security just not only all about a one layer, it's like a multiple layers and correlation between those layers and trying to figure it out, how we need to connect the dots, making sure that we have a good story before we go further and perform our further analysis or any kind of experimentation. So based on all these things, we analyzed a couple of CNC panels. We were working in the same field for a couple of years, and then we came across, we didn't find one specific experiments were not conducted in this context, in which we really want to look like, okay, dump the data, dump the URL list, basically the CNC URLs, and try to dissect those URLs to understand the security intelligence, or basically to gain more security intelligence out of it. What I mean by that, I want to check how the domains are generated. I want to check how many random, what the entropy of that URL is. I also want to check, how many CNC URLs were using HTTPS, how many were using Tor communication channel. So these kind of things like that try to get you a feel about what we are going to obtain as a part of the security intelligence. And you can use that intelligence to build detection solutions. You want to mine some data out of your Splunk, you can use that. If I see these kind of patterns, this kind of stuff, feed it into Splunk app, and then you can clearly see what you can out of it. So we did this empirical analysis, try to see what do we want to cover. So in this particular case, we want to basically look into where domain names are not used, only IP addresses are used, non-standard HTTP POST, Tor-based web communication, DNS-based CNC communication, encrypted communication channel, how the botnet C&C panels are deployed. Like what kind of web technology the attackers are using to deploy these kind of channels, right? It's PHP, ASP, ASPX, whatever it is all about. We really want to see, and we want to perform a quantitative and qualitative analysis on the top of it. Because sometimes you can get when we're performing experiments, we really want to see the volumes, right? I mean, typically in the field of, just an example, in the field of SCADA, right? People say, we don't have enough companies in that space that build a protection or detection solution in that context. The reason for that is we have only see very few set of attacks. For example, Stuxnet, Dooku, although they were very aggressive, but the volume, not that high. So that actually derives the market to a certain extent. But talk about Bitcoin mining, talk about other botnets that are using standard. These have been going for years and years. And why we have like antiviruses still existing, firewalls still there, although people are not happy with antivirus, but it still has to be on your machine. So that actually resonates back to my earlier point. Security is not about only one control, but multiple controls and the correlation among them. We will also want to look at perform the entropy mapping. Because let's say you want to write some fuzzing tool, you get a one CNC URL, and you're looking at that particular URL, and you want to fudge more. And then you write a Python code or any other code, and then you can go after, okay, take this URL as a baseline, try to iterate the web page name, try to iterate the numbers and stuff like that. So when you have an idea and you have a control of certain set of data of the CNC URLs, you can clearly see what kind of entropy is being set up for that URL. So that actually helps you to write some of the URL fuzzing tools and try to make sure that whether you can find more CNC panels out of it. For example, we have seen recently, still the domain is the same, but the attackers have deployed multiple CNC panels on the same domain, or one panel on a one domain and stuff like that. But usually we understand that, okay, if there is a one domain, one resources, there only say one CNC panel will be there. No, but there can be multiple directlies, multiple CNC panels will be there. This we have seen earlier, and we came across that this is also an important fact when you study botnet in that context. So considering all that scenario, so we clean the data, we look at that stuff, and some inferences were very, very good. So we came across that whenever the HTTP communication takes place, right, it is not necessary that in the, let's say, bot is sending HTTP post request out. So there is a host header in that. It's not necessary that host header has to have a domain name, which means that if the bot is actually sending the HTTP traffic using an IP address as the destination, there will be no DNS traffic for that. And that if your solutions are based on the artifact that, okay, we need to first see the DNS traffic, then the HTTP traffic, that it basically bypasses it. Because there is no domain, browser is not going to resolve the domain. It's still going to initiate a socket connection back to the IP address and start sending data on the fly. So these kind of things are very important. And we see that 18%, close to 18% was like the deployments that we analyzed for the CNC. They were actually using IP-based communication, but still, as we discussed earlier, the volume-based, right? You look at the DNS-based CNC communication, 81% were using the domain names. So it makes sense. We need a DNS-based solutions that actually, dissect the DNS traffic and gives us the idea, right? What are the abnormalities in the DNS traffic is, right? The domain generation algorithms, the DNS tunneling, and all those sort of things. But this actually gives you an idea, like domain names are still being manipulated to a greater extent. So we also look into the non-standard HTTP ports. So I have a lot of discussions going in a community where people say, if you're doing HTTP connection, either it's going to be on port 80, 443, 8080, 8081, and stuff like that. That is not entirely true. I mean, you can deploy web server on any port, just you have to bind on that particular port to start listening to your web connections. So we found that at least not enough, but still 1.2 to 1.3% out of 12,000 CNC URLs that we analyzed, they were actually using the non-standard HTTP ports, which means that if at the firewall or at any place, if your solution is just, or any signature that you have deployed as a part of your security operation that is only looking into, okay, TCP port 8044388080, it can bypass that rule on the fly. So this is also an interesting intelligence that we need to incorporate into the tools. Encrypted SSL connections, yes, we've seen that where, there were no validated certificates, but it was just only 0.5%. So still, adversaries, botnet operators, or attackers are going after clear text HTTP communication to a great extent. It doesn't mean that they are not using HTTPS. Advanced botnets might be using, but for the distributed infections, the attacks that are not pretty much targeted in nature, they are actually go after, okay, we don't care, we just want to send the data out. And why they are able to abuse HTTP protocol? Because it's a very default configuration. Every firewall needs to allow the HTTP traffic because that's how we browse the web. So they are actually mimicking that behavior, abuse some HTTP communication channel, and then send the traffic out of it. And then you need to have IDS, IPS, whatever it is there to actually dissect that content, making sure that nothing, sensitive goes out. But when you try to correlate all this kind of information, it gives you a very different scenario looking at how you need to build a solution. You want to define machine learning. You want to define some algorithm based on that. You want to go after natural language processing, whatever it is. This is the intelligence that make your machine learning algorithms out of the flow. Sometimes you can clearly see anomalies based on the data, but this intelligence, these kind of intelligence makes it way different, way advanced when you build, when you use data-based approach for detection and protection. Server-side deployment, PHP is the preferred choice, right? Open source, easy to code and all that. 96% out of those URLs were using PHP-based CNCs, right? So the way they have deployed command and controls, the way they have written is using PHP. We saw only 0.625 were using ASP.NET, stuff like that. So it basically, based on the volume-based analysis, at the end of the day, it's done. It's the PHP is the preferred choice. So when you're building your signatures, your rules, and your other stuff like that, that is the intelligence you really need to go after. Okay, I can just chop off the window for the other set of server-side deployments, but for this particular one, I need to have a stronger rules. We look into the CNC panels deployed on the compromised WordPress, because WordPress, Joomla, and all of the kind of thing, they are being, some kind of vulnerabilities came in, and then you just simply run the exploit, start deploying the web resources, web pages, either used for distributed infections or other stuff like that. We still found that the attackers use the compromised WordPress deployments 4.8%, which is still a good number considering that. So considering all that in Allure, we typically pick into the 7, 8 or other kind of metrics, trying to these variables and build a matrix out of it and try to get feel that, how these botnets are being operating, right? We understand the architecture, we understand the design components, but at the end of the way, these stats, these numbers gives you a feel that, where we need to go after when we try to build an advanced level of network detection and protection solutions. Another one important one is the, that how the top-level domains are being used. Like, so when the attacker is registering a domain, what kind of domain it is going after? It's a com, it's a org, or whatever it is. Without a doubt, we found that approximately like 40 to 45% or 38 to 40% exactly were using the .com domain. Right? So it means like .com, they have their CNC deployed on a like abc.com or some stuff like that. And similarly, we analyze a lot of things, .ru, .net, .org, .biz, .info, heavily being used domains where they have deployed their CNC panels. Moving further, just the Entropy ones, we found that the majority of URLs were not that random in nature. So let's say you have a abc.com, and then you further go ahead, there's a resource one, and then there is a web page name. You can still build a fuzzer, and then you can still keep on running the fuzzer using different resources. And then you'll find that if you basically, it resolves, it actually accepts your request, you get a feel of it that there's a similar kind of resources there. So from the Entropy perspective, we didn't find like they were not generating the CNC URLs to a greater extent. So I think we're running just close. I just want to a little bit talk about the arms race. We all know about that. It's all about attackers and defenders. But again, at the end of the day, advanced exploits are coming up, advanced security, protection, and detection mechanisms are put in place. But still, we see security breaches and all that. This race is never going to be ending. Whoever thinks that they're going to end the race, then the market will be gone, right? So most important artifact is who is going to take the first step, right? As a security practitioner, researchers, who's going to come after building strong security, intelligent-driven solutions based on what we have seen in the history and what we are expecting it to coming in the future. But again, at the end of the day, we are dealing with the world where data movement is all-time high, complexity, components, the way they are designed, all complex. Your data is just left your phone. You don't know where it is going on. We have seen many cases where we just don't have any clue. We talk all about privacy all the time, but the world works in different way. This is what the reality of the world we live in. So considering all that scenario, at the end of the day, we need to be proactive. We need to share the research with the security community and making sure that we build stronger protection and detection solutions. So I think I'm pretty much on my time. So if you have any additional questions, we can talk or we can talk a bit later. All right, thank you.